Hello guys, I would like us to look at denary and binary numbering systems. Now, denary or decimal system is basically the system of numbers in everyday use, using digits 0 to 9, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It is said to have a radix of 10. So it has a radix or base of 10, and the binary numbering system has a radix of base 2, and it basically uses the digits 0 and 1 only. So I would like us to look at conversion of binary to denary and vice versa. So conversion of binary to denary. Let's say you're given a binary number 11011 to base 2, and then you're being told to convert this to denary. So how exactly do we go about that? So I would want to write this number like this, first of all. So I have 1, 1, 0, 1, 1. Then this last term, so it depends, are you looking at it as first or last? You multiply it with 2 raised to power 0. This one with 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4. So this is basically how you carry out this: multiply, multiply, and then add them all up together to get the value of your answer in the denary form. So this basically gives us, so multiplying this, we get this 2 raised to power 1 is 1, 1, 1 plus 2 raised to power 1. This is 2 plus, this will give 0 plus 8 plus this will give 16. So adding this all up, we're going to get 27, which is in denary form. Hence, it's to the radix or base of 10. Let's take up another example. So let's say you're given your binary number in decimal form. You have like 0.1011 to base 2, and then you're being told to convert it to denary. So convert this to denary. So we are going to write it down. We start from 0. So we have 0.1011. Now, since this are after the decimal point, this is going to be multiplied by 2 raised to power 1. This is going to be multiplied by 2 raised to power minus 2. This is going to be multiplied by 2 raised to power minus 3. And this is going to be multiplied by 2 raised to power minus 4. And then we add them all up. We add them all up. So what does this give? So 0, it does not really matter. 0 multiplied with anything, we are basically still just going to get 0 here. So yeah, we still get 0 there. If we take, let's say 2 raised to power 0, multiply, you'll still just get 0. So 2 raised to power minus 1, that will give us a half. So we add in between them, plus 2 raised to multiplied with 0, we'll get a 0. This will give us 1/8, plus this will give us 1/16. So adding all this up, we'll get 0.5. So this will give 0.5. So we'll have 0.5 plus 0 plus 0.125 plus 0.0625. 0.0625, and all this will give us 0.6875 to base 10. So this is it in denary form. Okay, finally, last example, let's take up, you have 101.01012, and you're told to convert this to denary. So we are going to be multiplying them with powers of 2. So I will write this so that we see the values that are before the decimal point and the ones that are after clearly. So I have 101, then point, I have 0, 1, 0, 1. So from here, this is 2 raised to power 0 is what we'll be multiplying with, this 2 raised to power 1, and this 2 raised to power 2. Then from the decimal points going to the right-hand side, we'll have 2 raised to power minus 1, 2 raised to power minus 2, 2 raised to power minus 3, 2 raised to power minus 4, and then we add up all these values. So we add up all these values. So what will this give? Adding them all up. So adding all this up, we will have, so this will give 4 here, plus, this will give 0, plus, this will give 1, plus, this will give 0, plus, this will give 0.25, plus this will give 0, plus this will give 0.0625, 0.0625. So if we add all that up, we get our answer in base 10, which is 5.3125 to base 10. So basically that's how we convert binary numbers to their decimal or denary form. So what if you're given a number and you're being told to convert, so you're given in denary, conversion of denary to binary. So now you're given when it's written in base 10, and then you're supposed to convert it to base 2. So this basically, we carry out this just using simple division. So let's say you're given a number like 47, which is to base 10, and you're supposed to convert it to base 2. So how do we go about that? We will be dividing 47 with 2 and then noting the remainder. So I have 47 over here. Then I am going to carry out division with 2. And then on this other side, I am going to note the remainder. Okay, so 47 divided by 2, we will get 47 goes into 2, we will have 23, and we will have a remainder of 1. Then if you take 23 divided by 2 goes there 11 times, we'll have a remainder of 1. Then 11 divided by 2 goes here 5 times, we have a remainder of 1. And then 5 divided by 2, we have 2, the remainder is 1. And then 2 divided by 2 goes there 1 times, and the remainder is 0. And then finally, if we take 1 divided by 2, we will obviously get a 0. Okay, we will obviously get a 0, and the remainder will be this one, because 1 divided by 2, it does not go into 2, so 0 will just remain with that 1, like that. So basically, these are our values, and in order for us to get our answer in binary numbering system, so the results are given by these answers. So we write them from the last one being the first digit all the way. So this is how we're going to express our answer. Basically just taking the values of the remainder. So our answer will be 1011111, and this is it to base 2. 1011111. Okay, fine. Let's take up another example. So that's basically it. We just note the remainders as we keep on dividing. Let's take up another example. Let's say we are told to convert. Let's say we are told to convert. We are told to convert 39, that is to base 10, we convert it to base 2. The procedure is the same. We're going to divide by 2 and note the remainder each time. So 39, we are going to divide by 2, and then on this side, we're going to note the remainder. So the first time we divide 39 by 2, it goes into 2, 19 times, the remainder is 1 because you get 38. 19 divided by 2, 9, 18, the remainder is 1. Then 9 divided by 2, because there are 4 times, the remainder is 1. Then 4 divided by 2, so 4 divided by 2 goes here 2 times, the remainder is 0. Then 2 divided by 2 goes here once, the remainder is 0. Then finally 1 divided by 2, 1 divided by 2, so goes here 0, the remainder is 1. So our answer, as before, is going to be these values. So these values of the remainder. So our answer in binary form will be 100,111, 100,111, and this is to base 2. Okay, let's take up another example. Let's say you're told to convert. So let's take up another example that is now in decimal. Number 3, you're told to convert 0.625. You're told to convert 0.625. This is in base 10, so you convert it to base 2. So how do we go about converting a decimal number to base 2? This is how we go about it. So we'll take 0.625. This time round, we are multiplying by 2. And when we multiply 0.625 by 2, we will get 1.250. And then we take this part after the decimal point. So we take 0.25, we bring it here. So 0.250 times 2. Again, what does that give? That gives 0.500. We take this part again, bring it here, 0.500 times 2. What does that give? That gives 1.000. Okay, so basically our answer is given like this. We note these values in front here. So this, then this. So 101 to base 2. 0 point, okay? So 0.101. This is going to be our answer in Denary, in binary form. Okay, fine. Let's take up another example. Number 4. Let's say you're told to convert. So let's have 58.3125 to base 10. You're told to convert this to base 2. Okay, fine. So let's start with 58, and then we can do the decimal bit after we are done with 58. So converting 58, basically what we are going to do is we are dividing by 2 and then noting the remainder. So dividing by 2 here, then it goes here, we have 29 times, and then the remainder is 0. If we divide 29 by 2, it goes there 14 times. The remainder is 1. If we divide 14 by 2, we get 7. The remainder is 0. If we divide 7 by 2, so if we divide 7 by 2, it goes there 3 times. The remainder is 1. If we divide 3 by 2, it goes here 1. The remainder is 1. And then if we divide 1 by 2, so it goes here 0 times, the remainder is 1. So the answer is going to be given in this form. So this is going to be our answer. This is going to be our answer in binary. So that's going to be 1110. Wait, 111. And then there's 0 here. So there's 0, then 1, 1, then 0, finally. Okay, so 111,010. That's what we have. Okay, fine. Now they're onto the decimal part. So what are we going to have for the decimal part? So for the decimal part, let's just do it beside it here. So we have our decimal part is 0.3, 0.3125 to base 10. This is what we want to convert. So first of all, start by multiplying it with 2. So 0.25 times 2. And what does that give? That gives 0.625. So we get 0.625. Then we take this part here. So that is 0.625 times 2. What does that give? That gives 1.25. Then we take this part here. That is 0.25 times 2. What does that give? That gives 0.5. Then we take this point here, which is 0.5 times 2. What does that give? 1.0. So we are done by the time it gets our value as just 1. And the number is going to be, so we write it this way. So we are going to have 0.0101. So that's going to be it. So joining these two, we will have 111,010.0101 to base 2. And that's how you convert from binary to denary and from denary to binary.